Section 11.6, area between two curves. We're going to look at several different situations in this section that could come about, and hopefully by going through the various different types of examples, you'll have a good grasp on how to determine the area using the concept of the definite integral. So for starters, let's look at this illustration. Would you agree that if I'm trying to determine the area, or let me call it the value of the integral at this point, but if I was to determine the value of the integral below the graph of f over the interval from a to b, that would include everything under this and above the x-axis, right? So everything here would be shaded in, right? What if I also determine the area below this curve, representing function g, over the same interval from a to b? That would give me this shaded region right there. So, would it make sense to you to find the value of this shaded region, which we will now call the area of this shaded region? Would it make sense to do what? Take the value of the definite integral f of x over this interval and then subtract off the value you would get from taking the definite integral of this function over the same interval. Hopefully it does, which leads us to this. So if you want to determine the area bounded by some closed interval a to b, you have to make sure you notate your definite integral in this manner. What do I mean by that? This is the most, I don't know about the most important part, but this is very important. Okay, so again, what do I mean by that? Why is it so important? The function you put in this definite integral first must be greater than, must be higher up on the graph than the graph of this one. Okay? So we'll be looking at that as we progress through these examples. Let's have some fun. Right. Example number 1, we need to find the area of the region bounded below by the graph of this function, y equals negative x to the fourth plus 2x cubed, and this function, y equals 0, from x equaling 0 to x equaling 2. This is going to be our a value. This is going to be our b value. So what we need to do at this point is we need to understand which graph is greater than the other. All right, which one actually is higher up when you look at it on the coordinate plane system versus the other. All right, so let's go ahead and take a look at negative x to the fourth plus 2x cubed. So do you see that if we look at this thing over the interval from 0 to 2, the graph of negative x to the fourth plus 2x cubed is greater than y equals 0. And y equals 0 is just the x-axis. So because that's true, we're going to set it up as follows. We would write down the definite integral, looking at the lower limit of a to the upper limit of 2 of what? F of x has to go first. That's going to be the function that is greater than some other function. All right, so this is our f of x. This is our f of x. This is our g of x, based on the notation we just saw, okay? So, and we also just looked at it graphically. We know this is greater than 0, all right? So this is actually how you're setting it up. If you don't set it up this way, you're going to get a negative answer. And we're looking at area, so we know the answer has to be positive. Okay, so let's go ahead and evaluate this integral. We would get what here? Well, we would get negative x to the fifth over 5 plus what? 2x to the fourth over 4 And we're going to evaluate this definite integral over the interval from 0 to 2. So that would give us what? Well, let's see. Negative 2 to the 5th over 5 plus 2 times 2 to the 4th over 4. And then because our lower limit is 0, we don't have to worry about subtracting anything off because what we subtract off will be 0. So whatever this is equal to, that's going to be our answer. So therefore, area of the bounded region here is going to be equal to what? Well, whatever this is, negative 32 fifths plus what? Negative 32 fifths plus, it's going to be 30, let's see, 32 over 8, that's 8. So I think we get, if we add these together correctly, I believe we get 8 fifths units squared. You can check that on your calculator if you like. All right, let's move on to the next example.